What's up everybody? In this video, we are going to review adding additional sensors to your motor driver distance detection. You may find that you need more than one sensor to help your robot detect danger. For this video, we will look at adding a second ultrasonic distance sensor. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our motor driver distance indicator sketch. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to Motor Driver-Multiple Sensors. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is Motor Driver-Multiple Sensors, and the description is a sketch where we will use multiple sensors for collision detection. Before moving forward, let's review what we previously built. Click Start Simulation and ensure the serial monitor is displayed. You will see our circuit start up and the LED will blink using our thinking pattern. If you click on the ultrasonic distance sensor, you will see a ball that we can click and move. When you do this, the distance will show up in our serial monitor. If we move the ball outside of the field of view, the serial monitor will show that it cannot properly detect a distance. Because of this, we want to add an additional sensor to improve our robot's ability to detect danger. Let's add a second ultrasonic sensor. Search the components using the keyword distance and select the ultrasonic distance sensor under Other Components. Connect the VCC pin to power on your breadboard using a red wire. Connect the GND pin to ground on your breadboard using a black wire. Connect the trigger pin to pin 2 on the Arduino and the echo pin to pin 1 on the Arduino. Since we know our code works for the first ultrasonic sensor, let's make use of that code to test our new sensor. In your variables declaration, change the trigger pin to 2 and the echo pin to 1. Click Start Simulation and ensure the serial monitor is open. Click the ultrasonic sensor and try moving the ball around. Check the values you are getting in the serial monitor. It's showing a 0. And the robot performs the avoid collision function. So why is this happening? If you look at pin 0 and 1 on the Arduino, you will notice an RX and TX. These pins are used to receive RX and transmit TX data using the serial port. In our setup function, when we write serial.begin, this uses the pins for serial transmission and enables us to debug our code. If we don't use the serial monitor, then we can use these pins. If you comment out the serial.begin function in our setup code and click Start Simulation, you will notice that our circuit works. We can select the ultrasonic distance sensor, and if we move the ball past the thresholds, we will see the correct operation. However, if you look at the serial monitor, nothing is displayed there. We still want to use the serial monitor, so let's explore if there's another option. Uncomment the serial.begin before moving forward. We are going to need all the pins connected to the motors and the other ultrasonic sensor. We could remove one of the pins from the RGB LED, but we made that cool thinking pattern, and it shows us what the robot sees. That's pretty useful. It looks like we don't have any pins on the Arduino to use. Or do we? We have our analog in pins. If you look at the Arduino documentation, while their main function is to read analog sensors, they have the same functionality as digital pins 0 to 13. Let's test this out. Click the trigger pin wire and move it to A0, and click the echo pin wire and move it to A1. In your variable declaration, change the trigger pin to A0 and the echo pin to A1. Click Start Simulation and ensure the serial monitor is open. Click the ultrasonic sensor and try moving the ball around. Check the values that you're getting in the serial monitor. Cool! It's working and we didn't have to remove any of our sensors. Now, we need to add code so we can read both sensors. Update our variables. Since we have two distance sensors, we need to declare variables for both. I'm going to refer them as my left and right sensor. You can use whatever terminology you want, just ensure you have each sensor defined. Update trigger pin to trigger pin right, and update echo pin to echo pin right. Change distance to distance right. We're doing this because we want to measure two distances, one for each distance sensor. Let's update our variables in our main loop. On line 92, change distance to distance right, and trigger pin to trigger pin right, and echo pin to echo pin right. In the remaining lines of the main loop, change distance to distance right. Let's test our circuit. Click Start Simulation. We're getting an error. You will see that the error being printed says, distance is not declared in this scope, and gives us a line number, 66. Remember, when we wrote our getDistance function, we used it to get and return the distance. So we could change this to distance right in our function. But remember something that is useful about a function. It is a reusable piece of code. With the way we have written the function, it will accept any pins that have a trigger and echo pin. So we can reuse the function for the left sensor. So what can we do? In a previous video, we examined local and global variables. This is an example of where we can create and use a local variable. Remember, local variables are created and used within a section of code. They are only accessed within the code that they are declared. Global variables are accessible anywhere within a program. So how do we do this? Add the word int before the word distance on line 66. So why does this work? Remember, when we write the word int before a variable, this is declaring and creating the variable. We declare and create the distance variable within our function and use it to return the value. Let's test this to see if it works. Click Start Simulation, and you will see that the circuit is working properly. Cool. Let's add the left sensor. In our variable declaration, copy and paste the declarations for the right distance sensor. Change the word right to left, and update the trigger pin left to 12 and the echo pin left to 13. Next, in our main loop function, let's update the distance left variable. Before we update the distance right variable, type distance left equals getDistance, open bracket, trigger pin left, comma, echo pin left, close bracket, semicolon, and add serial.print, open bracket, distance left, close bracket, semicolon, and serial.print, open bracket, open quotation mark, space, close quotation mark, close bracket, semicolon. Click Start Simulation. Click on either of the ultrasonic sensors and move the ball. You will see that our circuit is reading the distance for both the left and right sensors. This should also illustrate how useful a function can be. With our getDistance function, we pass the trigger and echo pin for whichever distance sensor we want. The last thing we need to do is update our case statements. In our first if statement, add vertical bar, distance left is less than or equal to 10, and add vertical bar, distance left is less than or equal to 20 in the else if. So what does this mean? We can add something known as a logical OR inside our if statement. What this means is that if either of these statements is true, it will execute the code. Click Start Simulation and test it out. You will see that when you test each of the ultrasonic sensors, it will trigger the robot to change its behavior. You now have two ultrasonic sensors that increase your robot's field of vision. At the end of this video, you should have a better understanding of how to connect two ultrasonic sensors to an Arduino and use a logical OR within a conditional statement.